everybody, and welcome back to Code with Marley. Today we're going to learn a little something where if you bend this little flex sensor, this senses how much flex there is, then it will print it out on the serial monitor, which pretty much means it prints it. So let's get started, if the button's going to work. There we go. So, first of all, we want to plug in our flex sensor, and I've already got the breadboard all wired up with positive and negative, so those are definitely powered up. So we're going to connect this directly to the breadboard, and just like the photo resistor, we're pretty much going to do the same thing. We're going to connect a little 100 volt, this one's 10K resistor, but you're going to have to usually fizzle around with that amount to get a good number. And I just learned that it's supposed to be that amount for most voltage dividers, around that amount. So here, what we're gonna do is on the other side, we're gonna, instead of connecting this here to the positive, we're gonna connect it to the negative, and then the other side that's empty on the resistor is gonna be connected with a positive wire to the positive lane. Now where the resistor is, which is also on the other side of the flex sensor, that's the same pin that we're going to connect to an analog pin. And I can't get it actually now. I need to go back down here to reach it. So here we go. Connect it all the way around to analog pin 0. Okay, so we got all the wiring done. Well, now we need to get into the code. So there we go. So first of all, I need to put a few comments before I forget. Pin, pin equals, let's just do pin equals A0 for now. Oh no, sensor is on pin A0. And in front of it, I can go int sensor equals A0 semicolon. So there we go. Now, the next thing we want to do here is in setup, we're going to write, it's actually quite simple. In setup, we're going to go actually we're gonna do no code needed in setup. Now we're almost done here. All we gotta do in loop now is we need to go int data equals the group analog read the sensor minus 787. I think that's it. You might want to fizzle around with this number when it comes to your sensor, but you can also just leave it alone for now, and then look, whatever number it gives you in the beginning, that's the number that we're going to put in here. So minus 0 for now. And in here I can write replace 0 with the number that your sensor starts off with on 0 degrees. On 0 degrees. So there we go. Now, that's bad. Okay, so we got this. The next thing we're gonna do, put a semicolon here. Don't forget your semicolons. Okay, the next line is, we need to go serial. Yeah, there is some code. One line of code there, okay. Nothing too crazy. Serial.begin, and guess what number is gonna go in here? Now, not everybody remembers this from the first drop, but I have remembered. 9600. And this pretty much just means allow you to print out some data. That's quite simple, huh? Anyways, have the Arduino. Now Arduino allow you to print things out. Have the Arduino allow you to print things out. That's a good way of saying it. And make sure that all of this is capital in the beginning. None of it was. Code that runs once. Code that runs over and over again. Code that runs over and over again. This is the code that runs over and over again. So now we go serial.println. You remember that word, right? Serial.println the data. So we're gonna start this out. I'm gonna call this flex sensor. There we go. And there we go. It's actually quite simple here. We got it done. So let's go over this again. Int sensor equals A0 semicolon. Sensor is on pin A0. Void setup. Code that runs once. Colon. Serial.begin 9600 semicolon. Opening parentheses 9600 closing parentheses semicolon. Have the Arduino allow you to print things out. Void loop. Code that runs over and over again. Into data equals opening parentheses and log read the sensor -0 semicolon. Replace 0 with the number that your sensor starts off with on 0 degrees. Then we have serial.println opening parentheses data closing parentheses semicolon. Print out the data. Okay, we got it all done. Now let's verify this to see if everything's working. And boom! See you guys next time. Well, no, not really. We still need to test it out. So see you at the testing place. See you there! Okay, so let's get testing. Open up the code panel. I already put the code in here. And you're going to press the upload button. I'm going to press this. And look, to do this, we're going to look at the serial monitor. And here we go. It says 767. So that's the number. You see it's at 0 degrees right now. Completely straight. 767. It gives us the exact value. So instead of 0, we're going to go 767. So then now we can start the simulation. And now 0 degrees equals 0. Isn't that good? But let's see. We got everything working right. It prints out the exact value that it is on. Isn't that great? So we got it working. Everything is working completely fine. We can change the value. And actually, we can make sure that if this is greater than a certain amount, then we can turn on an LED and say, oops, something's weird here. So let's do that. Let's get an LED. And we put the LED right over here. And now we're going to have an output of digital pin 7. From digital pin 7, this goes out and around into a resistor. And the resistor goes into the LED and then the dirty or black water, that's why it's probably black wire, it goes right back into the ground. So here we go, put a 220 ohm resistor. 220 ohm resistor. So there we go. Now let's edit the code for this. I'm going to edit it right here. So we're going to go if, first we need here, if the data is greater than a certain value, let's say if it's greater than half, if data is greater than or equal to, let's do 70, then we want to go digital write. That means we set the data on the pin number. What's the number going to be? 7. As, do we want it on or off? On, of course. We set it to high. Else, if that's not the case, we go, what line of code are we going to write? Let me guess, you're shouting digital write 7 low? I hope so. Digital write 7 low. I hope that's what you were saying there. Let me know what you were saying there, okay? And I'm gonna have now, from now on, I'm gonna have a question of the day, okay? And that number, and you guys are gonna tell me back in the comments of what it is, okay? And let's start it all up again and see how it's going. So right now it's 0, and if it's greater, you see it goes on. That's not that bright. What's the problem here? What's the problem? What's the problem? Are these ohms or kilo ohms here? 220 ohms, yes. What if we don't put anything there? If anything happens, you're gonna go ahead and try to figure out what's wrong. As you can see, it's all the way and it's not bright enough. Okay? So let's do a quick test by connecting this directly to the positive lane to see if it's gonna be just a problem here. Okay, so the problem is that the digital pin 7 is not sending up enough data. Not sending out enough stuff. So we're gonna maybe try to go on another pin. That's our first guess on what we can do. So connect it to D8 instead of D7. But what does that mean? Oh, you gotta add the code. And what number is this gonna change to? Are you saying 8? Good. So now, here we go. Come on. There's a problem here. A very big one. A very, very big problem. What about we try changing the color? Maybe it's that we can't see it that well, and this thing isn't sending out 5 volts. Let's see. Let's do a white one. This is not going that well. This is not going that well. This is not going that well. What about if we remove this line? Maybe that there's being a little bit annoying. Let's see. Is that there the problem?
It's 1930.
No, not the problem. That there is not the problem. But then what is the problem? But then what is the problem? Oh, what is it? Just what is the problem if that is not it? Oh, we can just go is greater than and see if that there works. No, not doing a thing. So, I know another thing that we can do. We can use a PWM pin like D9 and go analog right. We can go analog right. Analog right. pin 9 as, what's the biggest number here? Not 1, not 10, 100 now, 1,000. Are you saying 1,000? I hope so. So, oops. So, let me copy this and paste it here. Oh no, here we want it to be 0. Oops. Well, right now it's not working that well. 0. So now it's off. And now it's on. Okay, we fixed the problem. Now we just need to go a resistor, a very simple resistor, just like we just now had. But we need to remove it for some testing circumstances. 220 ohms, and this should do the trick. 3, 2, 1, the moment of truth, it's on. So we got a very simple setup here, and it's even printing out values right here. It tells us exactly how many degrees it's getting bent. Right now it's greater than 70, of course. That's not greater than 70. That's not. That is greater than 70 still. Let's see. And we're going down. Okay, now it's less. So as you can see, it's not exactly the value. Here it goes 197. So that's a little bit of a problem, but we can fix that another day. Well, we might go want to change 70 to something a little else, because that's not halfway. I'll try 90. That should be good. It should be about halfway. It's even 88 that's greater than 90 though, which is a little bit annoying. So 59 equals 92. What about 50? Let's try 50. Yeah, that should be good though. I thought I just saw that thing turn 3. Anyways, we got it quite simply. And see you guys next time. Bye!